Alrighty, so let's go ahead and take a look at the first page of the Unit 10 test review. Number 1, it says find the circumference in terms of pi. Hint, this is a special right triangle, which is good review because we're going to be needing special rights for Unit 11. So take advantage of this, recall special rights, and then, do this problem and be prepared for Unit 11, okay? So I have a special right triangle. It's inscribed in a circle. And note that we have 2 tick marks indicating that these 2 sides are congruent. So if this is 6 root 2, then this side has to be 6 root 2 as well. But the question here is, what type of special right triangle is this? Is this a 30-60-90 or a 45-45-90? Well, because we have an isosceles right triangle, meaning that we have 2 sides that are congruent, and also it's a right triangle here, we're going to be using 45-45-90. So that means that this angle here is 45, this angle here is 45, and then we have our 90 already drawn out for us with that, square. So what I'm going to do now is I'm going to label. Across from 45 degrees, 6 root 2 is equal to A. Across from 45 degrees here, this 6 root 2 is equal to A. And then lastly, across from 90 degrees, this side here, which is the diameter, how do we know that that's the diameter? Well, it's a segment, or particularly, it's a chord where it goes through the center of the circle. I'm going to call the diameter D, and I'm going to set that equal to A root 2. It's A root 2 when you have a 45-45-90. Okay? Well, this here, note that A is equal to a number. A is equal to 6 root 2. That means that D is equal to 6 root 2 times root 2. Therefore, D is equal to 6 times 2, because root 2 times root 2 is 2, and you multiply that by 6. So D is equal to 12, and that's our diameter. So if D is 12, the diameter is 12, and I'm trying to find the circumference here, the circumference formula is C equals 2 pi r, or C equals pi d. But the best formula to use, because I have the diameter, is C equals pi d. So C is equal to pi times 12, or C is equal to 12 pi. And this is your answer. Number 2, find the length of arc JK. Leave your answer in terms of pi. And this is where you're going to use your calculator for this one. Because it says length, you have to use the arc length formula, which is L equals x over 360 times your circumference, which is 2 pi r. You need your central angle, and you need the radius in order to answer this problem. So if I look at the circle here, I'm given the central angle. But what's the radius? Well, currently the diameter is 15. But I only want half of that. So I'm going to take 15 and I'm going to divide that by 2. And your radius is going to be 7.5. Okay, so I have the central angle and I have the radius. Let's go ahead and plug that in. Let's go ahead and plug those in. So I have L equals 105 divided by 360 times 2 pi 7.5. And then what I'm going to do is, oh, well that's great, because look, I'm going to multiply the 7.5 times 2, which is 15. Y'all, 2 pi r and pi d are the same thing. You don't necessarily have to divide by 2 in this case, but we're so used to having the formula as L equals x over 360 times 2 pi r, which is just a habit, and that's kind of, one of my habits. So really, you didn't have to divide by 2 to find the radius. You can just leave it as pi d. So you have L equals 105 over 360 times 15 pi. Okay? And this is where I'm going to use my calculator. You're going to input 105 divided by 360 into your calculator, and you should get this decimal. Then you're going to multiply that by 15. And this is where you need to turn that decimal, after you multiply by 15, you're going to turn that decimal into a fraction. So you're going to press math, enter, enter. So your answer should be L equals 35 over 8 pi. Because we have to multiply that number that fraction we got from our calculator by pi, so we can leave the answer in terms of pi. And this is what we want. So the length of this particular arc is 35 over 8 pi. And I want to make a quick note. Yes, sometimes you will be given the diameter and all you have to do is just write 15 pi. But sometimes you're going to be given the radius instead, and you're going to be using this formula. L equals x over 360 times 2 pi r. Alright, number 3. In circle Q, okay, so we can assume that the center point is Q. Find the length of arc ST if QT is 9. So here's QT. This here is 9 centimeters, by the way. And we're given the central angle, and I'm trying to find the length. That means I'm going to be using the arc length formula. Okay. Note that, again, we're dealing with a center point. The center point to the circle is 9 centimeters. That's our radius. And that's what I mean by what I said earlier, because we're not given the diameter, we're actually given the radius, so we're using this formula. Okay? So I write L equals the central angle 60 over 360 times 2 pi 9. I'm going to multiply the 2 and the 9 together. So that's going to be L equals 60 over 360 times 18 pi. And then let's do this. I'm going to get my calculator out. I'm going to input 60 divided by 360 into my calculator. And then we'll multiply that by 18. So, well, that's great. I don't need to convert that 3 into a fraction because 3 is basically a whole number. And that's essentially 3 over 1, or just 3. So L is equal to 3 what? 3 pi, and this is your answer. Number 4. Segment, let me move this up so I can read the problem. Segment TP is tangent to circle M at point T. So, remember, a segment that's tangent to the circle, it means they intersect the circle at one point. So, this is what they're referring to. This is the tangent segment to be exact. If the measure angle TMA is 76 degrees, what is the measure of major arc TBA? Okay, so where is the measure angle TMA? It's right here. It's 76 degrees. And it's asking us to figure out what the measure of the major arc TBA is. Well, you really need to know your definitions, theorems, all of that in order to answer this question. Because look, you have the measure angle TMA. So the measure angle TMA is 76 degrees. But that's also the central angle. Because it's an angle where the vertex is dead set at the center. So you're really dealing with a central angle right here. If the central angle is 76 degrees, then its intercepted arc is also 76 degrees. So then, how long is this, or specifically, how long is this arc? Well, we know that a circle is 360 degrees. So I'm going to do 360 minus 76. And that's going to give me the measure arc TBA, which is 284 degrees. And that's your answer. Number 5, find the measure angle B. Okay, so we have an angle inscribed in a circle. Note that the vertex is on the circle. So if the vertex is on the circle, you have to remember that this angle here is half of this arc. So the measure of angle B is 1/2 of the measure arc AC, which is 60 degrees. Therefore, the measure angle B is just 30 degrees. Very simple. Number 6, find arc AB, or the measure arc AB. Okay, so again, the vertex is on the circle. So if I'm given the angle this time, then all I need to do is I'm going to take this number and then multiply that by 2. So the answer here is 88 degrees. Number 7, if the measure angle KNM is 97 degrees, then find the measure of angle KLM. Okay, so we have a quadrilateral. And one of the theorems that we discussed in class is that if you're given a quadrilateral inscribed in a circle, then its opposite angles are supplementary. Meaning you take these opposite angles, you add them together and set it equal to 180 degrees. Okay, so L and N are opposite angles, or opposite to each other. You're going to add those angles and equal that to 180 degrees. And then you're going to do the same for angle K and M, but we're not given anything for those two angles, so ignore. If I'm trying to find the measure of angle KLM, well, we're going to call that X, because that's our unknown. So you're going to take these two angles. Once again, you're going to take these two opposite angles, and then you're going to add them together equal to 180 degrees. So it's X plus 97 equals 180. So your answer here is X equals 83 degrees, which is the measure angle KLM. Alright, here's number 8. If the measure angle MLK is 2x minus 1, and the measure angle MNK is 8x plus 1, solve for x. Okay, so we're going to be using the same figure over here. Let me go ahead and erase this. It says the measure angle MLK, which is this angle. I'm going to write 2x minus 11 here. And then this angle, MNK, is 8x plus 1. All I got to do is, since those two angles are opposite to each other, you're going to add those expressions together and set them equal to 180. So 2x minus 11 plus 8x plus 1 equals 180 degrees. So you get 10x minus 10 equals 180. And then you get 10x equals 190. So therefore x is equal to 19. And this is my answer because I'm not being asked to plug anything in. I'm only solving for x, therefore x is equal to 19. Number 9, what is the measure of angle 3? So this is the angle that I'm looking at. Notice that we're dealing with an inscribed angle. We have the vertex, which is on the circle. That means that the angle here, so the measure of angle 3 is 1/2 of its intercepted arc, which is 198 degrees. So 1/2 of 198 is 99 degrees. So that's the measure of angle 3. For this one, it says find the measure of angle 6. Okay. So the first thing that we have to note is that this is the angle that I'm looking for, and there's nothing over here. But we know that this arc is 228 degrees. So if I do 360 minus 228 degrees, then that's basically the measure of this arc. So 360 minus 228 is 66. Oh, just kidding. I'm jumping too fast. 360 minus 228 is 132 degrees. So this arc here, the measure of this arc is 132 degrees. So now that I have the arc, I can figure out the angle. Again, since the vertex is on the circle, the measure of angle 6 is 1/2 of its intercepted arc. And that's 66 degrees. Number 11, find the measure angle B and the measure arc AD. Okay, this is really blurry, but that's fine. The measure of angle B is right here, and I have to figure out the measure arc AD. So there are two things I gotta find. I gotta find this angle here, and I gotta find this arc here. Okay, well, if you have a bow tie, something like this, where you have two angles that share the same arc, then you can safely assume that these two angles are congruent to each other. And I've already proved why in class, so when you see something like this, you're going to set those expressions equal to each other. So you have x plus 24 equals 3x. So subtract both sides by x. You get 24 equals 2x. So therefore x is equal to 12. Okay, so x is equal to 12. Now, what I'm going to do here is I'm going to take this 12 and plug it into 3x. So that's going to be 36 degrees. So this angle here is 36 degrees. and the vertex is on the circle. So the measure of angle C is 1/2 of its intercepted arc, which is AD. So 1/2 of the measure arc AD. Okay, so the measure angle the measure angle C is 36, equal to 1/2 of the measure arc AD. And I'm going to replace the measure arc AD with X, because that's basically my unknown. So what do I have to do on both sides to get X by itself? Well, I gotta multiply both sides by 2. So the 2 2's cancel, and you're left with X on the right hand side, and you're left with 2 times 36, which is 72 degrees. So X, or the measure arc AD, is 72 degrees. Number 12, what is the measure arc QR? So note that you're given a triangle where one of the side lengths go through the center. One of the side lengths goes through the center of the circle. So this is the diameter. So if you're given a triangle where one of the side lengths goes through the center of the circle, therefore it being a diameter, then you can safely assume that this angle is 90 degrees. So you can take the sum of these angles and set it equal to 180 degrees. So you have 3x plus 1 plus 90 plus 7x minus 1 equals 180. And then you're going to be left with x equals 9 as your answer. So I'm going to just, here's my equation, and then there's your x. But it's asking you to find what the measure arc QR is. So where's QR? This is QR. So this is what I need to do to find QR. Let's do this. Note that we have angle P. I'm gonna go ahead and erase all of this because a lot of highlighting can be quite confusing. So if we just focus on what we really need to do here in this step, then it's going to be clear on what we need to do to reach our goal. So if I look at angle P, here's angle P. Note that this angle here, its intercepted arc is this, QR, which is exactly what we need to find. If I know what x is equal to, which is 9, I'm going to plug it in to P, which is 3 times 9 plus 1, right? 3 times 9 plus 1. That is 28 degrees. So this angle is 28 degrees. So again, if the vertex is on the circle, then this angle is half of its intercepted arc, or this arc is twice this angle. So the measure arc QR is 28 times 2, which is 56 degrees. So this is what I'm trying to find. It's 56 degrees. Number 13, find the measure angle 1. So here is measure angle 1. Note that we're dealing with two intersecting chords. So if the vertex is inside of the circle, you're going to look at where angle 1 is. It's the right angle, So you're going to look at the adjacent arcs. You're going to look at the right arc, and you're going to look at the left arc. You're going to add those two arcs together and then divide by 2. If you were looking at this angle here, you're going to be looking at the top and also the bottom. You add those two arcs together and then divide by 2. But in this case, we have this right angle, so we're going to take 50 plus 56 all over 2, which is equal to the measure of angle 1. So 50 plus 56. Let me get my calculator. That should be 106, right? So 106. Yeah, again, I cannot do, if you know me very well, I cannot do arithmetic in my head. 50 plus 56, that is 106, good. And then you're going to divide that by 2, which is 53 degrees. That's how long this angle here is. Okay, and that's also how long this angle here is as well, because of definition of vertical angles. Okay. Number 14, find the measure angle R. Notice that the vertex is outside of the circle this time. So if you recall, it's the big arc minus the small arc all over 2 to figure out how long that angle is. So measure angle R is what I'm trying to find. You're going to do big arc minus the small arc over 2. And then that's going to give you 40 degrees. And that's your answer. And y'all, that's the first page of the review. I'll see you next time.